Hey folks, how's it going? This is Mr. Moray coming to you with a recap of the homework catnapping of Archie and Pi. I'm sorry I was not able to get to class today. Unfortunately, I didn't feel well. I know I was there earlier on the day, but I just wanted to make sure I was good to go for tomorrow, especially it's an important day. It's our block day. It's our day to assess and also kind of move on to the next thing. So I thought I'd make this video to help you at least maybe answer some of your questions in terms of how you tackle solving problems using quadratic models. These were some complex problems, but I thought that I would kind of try to make it a fun experience. And even though these situations were not necessarily relevant to your daily lives, a lot of the times the problems you see here are like write the equation that goes through these points instead of really challenging you and getting you to look at things as more than just points. Maybe not relevant to your daily life, but not just, a couple points that it goes through. Okay. So, in terms of this one, you had a number of clues you had to find. The first clue was from Mrs. Esmeralda, and she saw the catnapper. The catnapper was 2 feet behind Archie before they made their move. Archie tried to escape by leaping through the air, jumping as high as 9 feet before landing 6 feet from where the jump began. It was too late though. The catnapper grabbed Archie. So one thing that I didn't see happening, and by the way, before I continue, you need to find the function that models the height of Archie X feet after the catnapper pounces. So one thing I didn't see us doing when you're given these problems is, I know that it's really tempting to say, I want the answer. I want to know what's the solution to this problem. But look, I want you to know that too. But you have to be willing to take the time to think through problems with multiple steps and not just expect the answer to come that easily. It would be nice if it works that way, but unfortunately it just doesn't. Okay? So when you're given information like this, I need you to summarize it so that you can more easily access what you need to know to solve the problem. So one way you do that is by making a picture. So here's my catnapper. Okay? And Archie is right here. All right. Now, what we know is Archie leaped through the air. And if we think about it in context, we now know it's got to be a parabola that looks like this. Okay? They were able to get as high as 9 feet before landing 6 feet from where the jump began. It was too late though. The catnapper grabbed Archie. Okay, so look, I know that you're going to say, hey, this is a lot of work. Why do I have to do all this work? Well, look, then I feel like a lot of the same people then also complain when they don't get all the points. If you want to get all the points, if you want to get the grade, if you want to be successful, and I see it not in terms of your grade, but also in terms of you understanding, then you have to be willing to invest the time to understand the problems through the diagram. Okay, if you're not willing to do that, then then the result is your choice is it might not be possible to get the kind of points that you want to get out of these problems. Okay, so let's look at the situation. We know that this guy is 2 feet behind Archie, and let's say, what do we need to find? So I always like to highlight what we need to know, right? What we need to know is the height of Archie X feet after the catnapper pounces. Okay, so X represents, so if we look right here, right now, the catnapper is at 0, 0. He's 0 feet from where he pounced. right? Because he's going to pounce. Okay. So what points do we know based on this situation? So what we know, we want the height. So we know right now he's on the ground. So his height is 0. And how far is he from the catnapper? Well, he's 2 feet ahead of the catnapper. So that would be 2, 0. Here, I know that he lands 6 feet after or from where the jump began. So 6 feet, not 6, but 8, because it's got to be this 2 plus this 6. And he's landing, so he's back at the ground. So what I have is 2, 0 and 8, 0. And since these are intercepts, what form would I use? I would use intercept form, okay? So the next step here is you're going to set up your intercept form. So you're going to put in your A because you don't know that yet. And I'm just going to make that look a little bit more like an A. So there's your A. Remember, every form has an A. And the reason that I give you another point somehow hidden in the context is because without that additional piece of information, it's not possible to necessarily find a definite A value. Then it turns into a number of things that work rather than one specific situation. So this is the backbone of the problem. You know that I have to have x minus 8 because when I plug in 8 for 8 feet ahead of him, where he started, I have to have 0 on the ground. When I plug in 2, before he pounces, right, I'm also on the ground. So 2 has to also go with 0. Okay? So now I need to know what is A. So to figure that out, I need to figure out another point, another XY combo. Okay? And this goes back to when you were trying to solve y equals mx plus b with a point, right? So let's say I told you that m was 3 and b was you don't know, but I know it goes to the point 0. How about I make it more complicated? 10, 33. So this is a question mark. Okay. What does b have to be? Well, what you did was you plugged in 10. Well, you plugged in the m, and you plugged in 10 for x, and you plugged in 10 for y. And you tried to solve for b. This is the exact same idea, but with a different type of function. Now I have my this, and I need to just solve for my a value, and so I'm going to use my point to help me figure it out. So they tell us the maximum y, but they don't tell us the maximum x. That is, I know that this needs to be 9 because the maximum value is 9. Okay, but what does x need to be? Well, what do we know about intercept form? Where is x of the vertex in intercept form as it relates to the intercepts? It's always right in between them. So if one intercept is 8, the other intercept is 2, what number is right between 2 and 8? It is 5. And let's check to see what happens here. So on the right, left I still have 9. Okay, 5 minus 8 is negative 3. 5 minus 2 is 3. So 9 equals negative 9a. So a equals negative 1. Okay? And so what I did here is I found the a that will ensure that when you plug in 5 for the x of the vertex, what will come out is 9. And so therefore my final function has to be f of x equals negative 1, or you could just use a minus sign. That would be just the same. Okay, so I have this will ensure that the intercepts are 2, 0, and 8, 0, the x-intercepts, and this will ensure that it points, not only that it points downward as it's supposed to. If you think about the jump in reality, not jumping like this, jumping like this. So if you think about the jump and you think about that value 9 that we have to have, and in fact we now know actually specifically that it's 5, 9. Okay, it needs to specifically not only be negative, but be -1. So I come over here, and I have x minus 2, x minus 8, and -1. All right, so please make sure you understand what I did in that particular problem, and then in a moment I will move on to clue number 2. All right, so Mr. Covarrubias gives us clue number 2, my former science teacher. I saw the catnapper too. While Pi was playing with a paper bag, the catnapper jumped to catch him. The catnapper was able to get as high as 8 feet off the ground, which happened 3 seconds after the jump began. 4 seconds after reaching their max height, the catnapper was back on the ground in time to grab Pi. Oh no! So you need to write a function that models the height of the catnapper off the ground t seconds after their jump begins. If this was a problem that you weren't able to do, I'd actually recommend at this point that you go back and listen to me read the problem again, because it's really important when you read word problems to fully understand them. You have to believe that everything you need to solve the problem is staring you right in the face. But unless you can really pick that information out and turn it into a way that you can recognize it, the problem is going to be difficult, if not impossible, to solve. Okay? So let's take a look and see what we can find. What is a few things of important information that we can take out of here? Okay, so one thing I see the catnapper was able to get as high as 8 feet off the ground, and it happened 3 seconds after the jump began. I also see that 4 seconds after reaching the max, they were back at the ground. Okay, so remember the pattern that we've seen so far. I usually give you enough information to guide you towards a form. In the last cases, it was intercept. And then I give you one more clue about a point that you can use to solve for the a value. So here, if we think about it, which point am I getting at? What I'm getting at is the vertex. And if we look at this as high as, think about that. That means the catnapper got no more than 8 feet off the ground, which means that we have a maximum value of 8. Notice that we also know that it happens 3 seconds after the jump began, and in this context, x represents 6 seconds after the jump began. So if 0 is when they first take off, then 3 seconds after the jump began would be represented by the number 3. So what we know is the what? The vertex. So given that we know the vertex, we should use which form? We're going to use vertex form. So what I have right now is I know that f of x equals a, x minus 3 squared plus 8. So what I have so far is a quadratic that we know for 100% fact will have either a max or a min at 3, 8. Because we don't know what kind of number a is, we don't know whether it's which one or which, but I bet that you figured out by now that it probably needs to be a max. So a probably needs to be a negative number, right? Because if you think about, again, jumping through the air, do people jump like this or do people jump like this? Think about when you jump in the air. Which of those looks more like what you do when you jump in the air? Okay? So I'm going to do this. Sorry, I just changed colors. So what's our other point that we know is in the graph? What's the only information we haven't used? Okay, take a look at this. So 4 seconds after reaching their max height. What's 4 seconds after the maximum height is reached? Well, that would be 4 seconds, right? There's already been 3 seconds. So 4 seconds later will be 7 seconds. And now they're back on the ground. So what does that represent in terms of height off the ground? It will be 0. Okay, so here's what I know. I'm going to set y equals 0. I'm going to go a times 7 minus 3 squared plus 8. Okay? Because what I know is that when I plug in 7, what has to come out is 0. Because that's what it means for 7, 0 to be on the graph. right? So one of the big takeaways that we have to take from this class into next year is that the graph of any function is just all the inputs and outputs, right? The things you plugged in and what came out, okay? So, let's see if we can simplify this. So 7 minus 3, that will give us 4. We square 4 and we get 16. Then we subtract 8 on both sides because we're solving for a. We divide by 16 and we get a equals negative 8/16, which is negative 1/2. And if you think about it, this checks with what we know. The negative, confirms that it's a downwards parabola, which is what we know it's going to be. And the 1/2 will ensure that when I plug in 7, and we can double check this, let's see what happens. So what if I do 1/2 times 7 minus 3 squared plus 8? Negative, okay? So this will become a 4. This will become a 16. Gotta remember to keep my negatives going. This will become a negative 8. And negative 8 plus 8 is 0. Okay, so what this means is our final function needs to be, I'll come here to the a, I now know my a, I'll erase and I'll replace it with negative 1/2. So it's negative 1/2 x minus 3 squared plus 8. The 3 and the 8 ensure that the maximum height of 8 occurs 3 seconds after the jump, and the negative a ensures that the jump is a downwards facing jump, and the 1/2 ensures that after 7 seconds they're back on the ground. Okay, so please make sure you understand what I did here in this problem, and then in a moment I'll go ahead and I will do the next problem. And by the way, before I do that, let's take a look. Negative 1/2 t minus 3 squared plus 8. Just want to make sure there's no other one that could be it. Yeah. So this was an error in solving. This was an error in solving. These were kind of errors in solving. This was an error and like if you got a plus, that was an error in interpreting, because this would give you a vertex of -3, an x of the vertex rather -3. Okay. So again, please take a moment and understand what I did there. Then in a moment I will move on to the third clue. Okay, so moving on. All right, Mr. Mithridy, no relation. I don't know if you saw the potential relation there. Okay. So, Mr. Mithridy says, I saw someone running with a cat that matched Archie's description. They were running for their getaway car when they jumped on a trampoline and over the fence. The trampoline was 2 feet from the fence and 1 foot above the ground, and the fence had to have been at least 6 feet higher than the trampoline. You need to find a function that models the height of the catnapper off the ground given a horizontal distance, k feet from the trampoline. All right, so let's see. This one we're going to need to visualize. I definitely got a lot of extra help questions on this, so this one would probably be best to try to draw a picture of. And you, again, really have to be invested with the picture. Okay, so we got to think about it. So we got a trampoline, and by the way, if we take a look at what we need for our function, it says we need to find a function that models the height of the catnapper off the ground, and the k, the x, which we call k in this situation, is the how far we are away horizontally from the trampoline. All right, so let's draw our picture. All right, here's my trampoline. So the catnapper comes, Here's my wall, my fence, and he goes, boom, and dumps over the fence. That's how I envisioned it happening. Okay? And I know it's not a perfect parabola, but that's the idea with the vertex. All right, so what do we know that we can incorporate here? Let's see if we can take a look at this and see what do we know that we can incorporate into this picture. All right, so I see a couple things already. I see that the trampoline, what do we know about the trampoline and its relative distance here? So what I know is that it's 2 feet from the fence and 1 foot above the ground. So 2 feet from the fence and 1 foot above the ground where he hits. Okay? And I also know that K represents the distance from the trampoline. So if I'm going to draw my X and my Y, X would come here, Y would go there. See if I can undo this because I just want to be really precise here. So let's try this again. So let's go ahead and here we go. So I got to draw this kind of on a slant. So here's my thing. So more or less, all right. So this point where he first hits the trampoline is here. Okay? So he hits the trampoline here. This is 0, 1. And he prepares to go over the fence. Now we know the trampoline is 2 feet from the wall. And we also know that the fence had to have been at least 6 feet higher than the trampoline. So the difference between just the fence and this point right here is 6. So what would that make the maximum point? Well, if I'm 2 feet from this 0, that would make this 3. And if I was 6 feet above, it would make this 7. So what I know is that the vertex is 3, 7. So for this to be true, I have to use what form? Vertex form. So I have A times x minus 3 squared plus 7. Now, based on the situation, I know that when I plug in 0, what I have to get is 1. So 0 minus 3 is negative 3, which when I square it is 9. So what that gives me is positive 9a plus 7. So 6 equals 9a. So, wait a minute. Oh, you know what I did? I don't know where I got 3 from. You know what? I did it to the 1. So it should be 2, 7. I was going to say, things don't seem to be working out. So I get 2, 3. All right, so sorry. So let's take this back a second. So, my apologies. So our vertex is 2, 7. So I have x minus 2 plus 7. So I have 0 minus 2 plus 7. The difference is 2. So I have 4a here because you're squaring 2, not 4. So let's take a step back for those of you who might be like, what's going on? So I messed up with my vertex. My vertex should have been x of 2 because I'm 2 feet from 0 over. And then 7 because I'm 6 feet up. So what I need to do is I know that when I plug in 0 for x, what I get is 1. And so that's what this looks like. So this is 2. 0 minus 2 is negative 2. So what I do is I square negative 2 and I get 4. I subtract 7. And I divide by 4. So a is equal to negative 6 fourths, or in other words, a is negative 1.5. And so replacing that, I get this function right here. Okay? So here, I use the situation to find the vertex. This brought me to vertex form. I use the 0, 1. This brought me to solving for A. I brought everything back. And I get my final vertex form. And if I look, here you're supposed to use K. So I would just, replace X with K. And if you want to use it in terms of X's, I would just ask in the end you bring it back to K's. But if you want to use it in terms of X's, just to help you do it in a way that's more compatible for you and more comfortable for you. But you in the end have to know that you're looking for a negative 1.5 K minus 2 squared plus 7. All right. So please make sure you understand what I did here in terms of how I broke down this problem and analyzed it. And then in a moment, we will move on to the next problem. All right, so here we go. So Miss Must. Oh, darn it. You just missed them. The catnapper and Pie just jumped in a car and sped down the hill. After reaching the bottom of the hill, they used their built-up momentum to shoot back up. They got back to their starting height 20 seconds after they first took off. 5 seconds after that, they are 25 feet in the air. You need to find a function that models the vertical distance of the car above its starting position in feet t seconds after it begins its journey. So look, again, there's so much coming at you in this problem that if you don't take the time to synthesize, to break down what you know and put it into a way that you can really go through the steps you need, it's not going to be possible. Again, you want the answer, you have to be willing to invest something to get there. Okay? So here's what I know. Let's take a look at some things. So what do we know about what's going on? So it reaches the bottom of the hill and then it shoots back up. So if we think about it, it's not vital, but it's helpful. What kind of shape do you think this looks like? I think it looks like a shape where it reaches the bottom of the hill and shoots back up. Which one looks like that? This one or this one? It's going to be the one on the right. All right, and what we know about these are that A is more than 0. So it's helpful in that regard. It will help us know that if we don't get an A more than 0, we need to go back and check something, okay? So in this case, the input is seconds after we started, and the output is how far we are above our starting position. So here's what this one looks like. Here's my car. It's going to go down. It's going to come up. So we know we have a few points. All right. So here's the reality. We have 4 points right now that are very significant, 3 of which are significant for any quadratic. We have an intercept, both an x and a y intercept. We have another x-intercept. We have a vertex. And we have a point on the line, on the curve. Okay? Now, right away, we can figure out a couple of these things. And let's see what we can figure out. So, in the very beginning, before they take off, we know that no time has passed and that they've not gone anywhere. So 0, 0 has to be a point on this graph. We know that they got back to their starting height 20 seconds after they first took off. So 20 seconds after they first took off, they're back at their starting height. We know that 5 seconds after that, they're at 25 feet in the air. So this would have to be 25. and this would have to be 25. So let's take a look and see what we can figure out. Also, what can we figure out about the vertex? We could say that the x is 10, but I don't necessarily know right now that there is an easy way to figure out the y. Right? Ordinarily, we would plug it in, but we don't have anything to plug it into. That's the issue, okay? So what I'm going to do is I'm going to try to use which form. And I should really get practice what I preach here and use the variable. I'm going to use intercept form. So I've got, in a sense, x minus 0. See, I'm falling into the habit of using x. It's very tempting to do that, right? We're so used to seeing x. It's hard to break out of it sometimes, even for people who do math all the time. So look, if I plug in 0, this becomes 0, so everything becomes 0. If I plug in 20, this becomes 0, so everything is 0. And now what I know is that if I plug in 25, what has to come out? 25. When you plug in 25, out comes 25. Okay, so what does that make A? See if we can figure out. So this becomes 25, right? 25 minus 0 is 25. What's 25 times 5 minus 5? That's 20. Okay? So, and this is all equal to 25. So if I multiply those together, see what I did? I got one step ahead of myself. So sorry, this 20. So this is 5. So this is 125. You should be subtracting 20. See, I got ahead of myself. I went right to the 5. All right. So now, how do I get A alone? I would divide by 125. Thought that number was getting awfully high. So I get 25 over 125, or 1/5. So that means I have to have f of t equals 1/5 t minus 0, which is just t. So if you ever just see a letter, like just you see the t hanging out like that, you know 0, 0 has got to be a point in the line. Because look, this literally means 1/5 times t times t minus 20. So as soon as any one of these three things are 0, you're multiplying by 0, everything is 0. And like, look, we know 1/5, right? That's obviously not 0, so forget that. So if you can make this 0, right, you'll have 0, right? Hence, t is 0, everything is 0. Okay, so that's another way to look at it. Okay, so please make sure you understand what I did in this problem, and then in a moment I will go ahead and move on to the next problem. All right, on to clue 5, Mr. Darjo. Mr. Darjo says, "You're almost there. I saw the catnapper rappel onto the top of MHS. Once the hook was 2 feet away, it reached a minimum of 4 feet above the ground. It latched on to the top of the building after traveling 10 feet from its original position, reaching a height of 36 feet above the ground. You need to find a function that models the vertical distance of the hook above the ground in feet after it has traveled n feet from the catnapper." He saw the catnapper. Nice. Okay. So, here we go. So, here's what we've got. We got this guy, the catnapper. Okay? and here's his hook. He's swinging it around, right? He's swinging the hook. What happens is the hook, here's the building. Hook goes down, it hits that minimum, and boop, swings up and gets to the building, okay? So here, what do we know? So this is why you draw pictures, and I promise you, you've got to take the time to do this. If you care about really maximizing what you take out of this, you have to take the time to do that, okay? So we know that once the hook gets 2 feet away, it reaches a minimum of 4 feet above the ground. Now, it's obviously not drawn to scale, but it doesn't have to be. That's okay. It latched onto the top of the building after traveling 10 feet from its original position. "36 feet above the ground." So I've got this point of latch right here. So what do we know? We know a point, this right here, right? So we know 2 things. We know the vertex is equal to 4. Sorry, not 4. 4 is the y of the vertex. Let's see if I can get lucky and move that. Nope, no such luck. Smart notebook. Okay. So it goes 2 feet, and it reaches a minimum of 4 feet above the ground. So he swings, whoosh. Okay, and then we have a point. It goes 10 feet, which is a height of 36 feet above the ground. So given this information, we need to use what form? We need to use vertex form. So we need to use n as our letter. So let's say I use distance. The distance after the hook has traveled n feet. So the distance in the air after the hook has traveled n horizontal feet. So the distance up and down, based on how much we've gone this, is given by this rule. A, which we don't yet know, times x minus 2 squared plus 4. So this ensures that the lowest point or highest point is 2, 4. We know that A is going to need to be positive to ensure it's actually a lowest point. And now what we're going to do is we're going to try to solve for A. So what point do we plug in here, folks? We're going to plug in for d of n, 36. And for x, we're going to plug in 10. So that ensures that the graph travels through 10, 36. So what I've got here is I've got 36 equals A. So this is 10 minus 2, which is 8. And 8 squared is 64. And we could really call this 64A. Doesn't really matter the order that you do it in. So in the next step, I'm going to subtract 4. And when I do that, I'm also going to switch this around and make it 64A, because the order you multiply doesn't matter. And when I divide, I see that A has to be equal to 32/64, and that is 1/2, and it's positive, which is what we've expected. So d of n, and this should also be an n, right, to stay consistent, equals 1/2 times n minus 2 squared plus 4. Again, the 2, 4 ensures that after the 2 feet, it reaches the minimum of 4. The minimum occurs because the A value of 1/2 is positive, and the fact that it reaches 1036 occurs because it's not only is it positive, but it's specifically 1/2. Okay, so I hope this made sense as to how I put this together. Please take a moment to ensure you understand this, and just remember d of n and f of x and y, they all mean the same thing. They're talking about the output of something when you plug in a number. So when you plug in something for n, this represents what comes out. And no matter what you call it, It's the exact same idea. I'm putting in a number and I'm seeing what comes out. And the number that goes in goes along the x-axis, and the number that comes out goes along the y-axis. So I put in 10 and 36 comes out. So notice 1036 is a point on the graph. Okay. So again, please take a second and ensure you understand how I got this, and then in a moment I will move on to the next problem. All right, I'm excited. I think we're going to get this guy. And by the way, in this last one, I believe it is right here, x minus 2 squared plus 4. Okay, so we've got him almost. Nice, we got him. So you see the catnapper and they see you. You run toward the catnapper for 3 seconds, then leap in the air towards them. 5 seconds after leaving the ground, 1 foot above the ground, you collide with the catnapper. By the time you've been off the ground for 6 seconds, you and the catnapper are wrestling on the ground. You need to find a function to model your height above the ground in feet s seconds after you begin to run at the catnapper. All right. So I hope at this point, if nothing else in the whole entire world, you have thought to break this down and make a picture. Because like honestly, and I should have said this by now, when I make these problems, I literally make my pictures to try to think of points that I could use to help you understand the problem yourself. So here's the situation that I have, right? So I'm going to make a picture. So I got the cat. So where am I at right now? So I see the catnapper. Okay. So this is me. This is them. They see me. I see them, right? I run towards the catnapper. Or probably the catnapper's back here. I run towards the catnapper for 3 seconds, then leap in the air towards them. 1 foot above the ground, 5 seconds later, I collide with them, bringing them down. And by the time I've been off the ground for 6 seconds, I'm on the ground. So there's a lot to break down here because I'm not giving you any explicit x values. So you have to read it through a couple times. So in this first read through, what I know is that I'm going to be running, I'm going to be jumping, I'm going to be colliding shortly before I hit the ground. And then at some point I'm going to be hitting the ground, right? Because it says I'm wrestling on the ground. So let's read through another time. So again, and if you want to get the points, you got to be willing to invest this. So I'm going to run towards them for 3 seconds. So now I know it's 3 seconds of running. I'm going to leap in the air. Here, between these 2 points alone, it's been another 5 seconds. I'll just do that in red. And then we're on the ground. Well, okay, so, and then by the time I've been off the ground for 6 seconds, now I'm at 0. Okay. All right, so again, second read through. See, if you take the time to do another read through, you're now pulling even more information out. So let's see what we have here. So I'm running, and I know it doesn't look like it, but when I'm running, just before I go to take off, how high am I above the ground? I am 0 feet above the ground, right? I'm on the ground. Think about the situation in your head. Imagine you're running towards someone, you jump in the air, you collide with them just before you hit the ground, and you guys fall to the ground together. Think about that. So just before I go to jump, how high am I above the ground? I'm 0 feet above the ground, right? I'm still on the ground. Then I jump, right? Then I jump. All right, now I'm in the air. Now, 5 seconds after I'm in the air, I collide. So how many seconds total since I began running, right, am I at? So it took me 3 seconds to run. Then I've jumped for 5 seconds. So since I started, it's been 8 seconds. And how high am I above the ground at this point? I am, it says, 1 foot above the ground. So that means 1, because that's what the Y represents, quote unquote Y. Now, by the time I've been off the ground for 6 seconds, so now if I ran 3 seconds, now 6 seconds, by the time it's been 6, I've collided and hit the ground. So 6 seconds after I took off, that's 9. And now I'm on the ground, that's 0. Okay, so, and by the way, this 3-0, I just filled that in now. We had talked about that earlier. So think about the situation, and I'm actually going to get up so I can visualize it out. So I'm running for 3. I'm about to jump. I'm at 3-0. I jump in the air. I collide. I'm right above him. I hit him at 8-1. We go down, hit the ground, and we're wrestling, and now it's at 9-0. So think about that in your head. Think about why that makes sense in your head. All right. So what I need to do is I need to now write the function that goes with this. So what I have is f of x equals, now what kind of form should I use? Given the information, what should I use? I would argue to use, again, intercept form. Because this will ensure when I plug in 3, 0, when I plug in 9, I get 0, and now I need to solve for a. So when I plug in what, I should get what? Sorry about that. When I plug in what, I should get what? When I plug in 1, so I'll do that. When I plug in 1, thought I changed ink there. When I plug in 1, right, I should get, no, rather, no. When I plug in 8, I should get 1, because I have an 8, which is an S, and I have a this, which is an, if we're going to go with the system, call it f of s. Okay, so we have a 1, we have an a, we have a 5, 8 minus 3, we have a negative 1. So we have 1 equals negative 5 times a, because this negative 5 times negative 1. So I divide both sides, and I get a equals negative 1 out of 5. Okay? So I have f of s equals negative 1/5 s minus 3 s minus 9. All right, and now in the slides there might be alternate. I know I might not have called it, I probably didn't call it f, but you now know whatever you see, whatever of s, that doesn't make a difference. You can call the function whatever you want. So you call it h for height, h of s. You could call it d of s for distance of s. You could call it e of s for elevation of s. There's a lot of things you could call it, but what's important to me is that you can look at a situation, you can create a visual representation of it, you can take from the verbal representation and the information, you can take that and you can write a function that ensures you hit all of the required points. Notice that for a parabola, unlike a line where we need 2, for a parabola we need 3. And so these two pieces, again, ensure we hit 3, 9. And the a being negative 1/5 ensures that when we plug in 8, what we get is 1. Okay, and so if I go to my clue, see if I can find it. Ooh. You got to keep going back and forth. S minus 3, S minus 9, negative 1/5. It's right here. I thought that was a 6. You nabbed him. All right. Notice the difference is the 6, it's not how much you've jumped in the air. That's how much you've jumped in the air. It's when you're actually at the ground. So you're adding the 6 to the 3. Okay. All right. So if you've gotten these clues, then you have got the cat napper. I hope that you were successfully able to do this, and I kind of overall hope you found the information helpful. Again, sorry I was not able to make it today. I just wasn't feeling well. I appreciate everyone who came to see me during advisory. I hope that was helpful. I'll definitely be available before school, etc., to help you. And I appreciate your persistence. Keep it up. Keep the questions coming. Keep working through the review. And remember, you can do it. All right. Thanks for watching. Feel free to like and subscribe to get the newest videos. Don't forget to love math, and have a wonderful day.